Hello everyone and welcome to this latest webinar from IHS Markit titled Data Center and DCI Optics. A look ahead. Today our panel will explore the world of data center and DCI optics and the solutions that are largely fragmented, where they connect, where they converge, and opportunities that exist for increased efficiencies. Our webinar is co-presented by IHS Markit and our partners Expo and Fujitsu Network Communications. My name is Alan Tatara, Senior Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight some of the features that are available for you on the webinar and how you can make the most of your experience today. So the console that you're looking at is completely customizable. You can open, close, move, or resize any of the windows that you have open on your screen and arrange the console exactly as you wish. At the bottom of your console, you're going to see a number of application widgets. Make sure you check these out during the webinar, but one button I do want to mention is the resource list widget, and this is where you will find additional material about our topic, including the downloadable slide deck from today's session, as well as other valuable information, including a special report authored by analyst Timothy Monks. And all these materials can be accessed and downloaded right from your console. And we do want to make this an interactive session, so you'll see a Twitter widget at the bottom of your screen. This means you'll be able to tweet directly from the console. And today we are using the hashtag DataCenterOptics. We will also have a live Q&A session directly after our presentation, so please submit your questions or comments at any time by using that Q&A box that you see on the left side of your screen. Just a quick note, this webinar is being recorded and the on-demand version will be sent to you within 24 hours. And if you encounter any technical issues during the webinar, just click on that question mark widget and you'll get the answers that you need. So now let me take this opportunity to introduce our panel. First leading our discussion is Timothy Monks. Tim is Principal Research Analyst in the Optical Networking Technology segment at IHS Markit. We are also joined by Sophie Legault. Sophie is a Director in the Transport and Datacom Business Unit at Expo. And rounding out our panel, we have Mohammed Sarwar. Mohammed is a Distinguished Global Product Planner at Fujitsu Network Communications. So welcome to our panel. We are honored to have you with us today. So Tim, let's get started with our presentation. I'll turn it over to you.
Thank you, Alan, and welcome everyone. We're going to cover DCI Optics, a market update, and we're packed with a lot of information, so I think I'd like to just jump in and get started here. First of all, it's common knowledge that the demand for bandwidth in optical networks is increasing dramatically. And what I'd like to do first is review some of the applications that are driving this demand. First, we have video streaming and augmented and virtual reality. With video streaming, Netflix now accounts for 30% of the bandwidth demand in North America and 15% worldwide, followed by YouTube and Amazon Prime, which also have very, very strong numbers. Streaming video now consumes 58% of all downstream traffic. Coming to this market soon, we have Disney, Apple, and other worldwide entities. Augmented and virtual reality and gaming are fast-growing markets. The augmented reality and virtual reality markets are at $1.8 billion in 2018 and growing fast. That's driving a lot of upstream traffic as well, and we're starting to see some commercial applications coming online for virtual reality, such as real estate, sales, education, and training. Mobile transport is also driving a lot of demand. 5G has likely been overhyped here in the near term, but I'm expecting that they will start driving demand, or 5G will start driving demand in the early 20s. And there's going to be a lot of low latency applications for this as well, including autonomous vehicles. IoT is coming on steadily. It promises millions of devices growing to billions of devices, communicating over the web 24/7. So it'll be less peaky and more of a background demand, but we see this starting to drive significant demand in the mid-20s. And then there's the cloud and digital transformation going on worldwide. Customers gain the power of information, but digital transformation really improves business economics and is likely become an imperative for medium and larger sized companies. And I expect this trend to continue. What we're also seeing in the past, kind of service providers have been the driving force with optical technology and optical networks, but this has moved over to web scale or hyperscale DC operators. And they're really the driving force in innovation for optical communications, from client optics, datacom, all the way to subsea and everything in between. And they're driving right now 400G to keep pace with the switching technology. We're expecting to see 400 gig clients to deploy in the second half of 2019. And we've started seeing some of the DCI deployments at 400 gig in embedded systems in 2018, but there's a lot of new technology coming out, including some from Fujitsu with 400 to 600 gig flex rate, and we see that starting deployment now in 2019. And we're likely to see 400 gig ZR begin deployment in the second half of 2020. This is an interesting technology in that it's the first technology to offer high faceplate density that's interoperable with coherent transceivers. And then there's also talk of 800 gig starting in 2020. One of the things that this has created is created a challenge because the pace of innovation is forcing faster product development cycles, but also higher development costs. So that's one of the challenges that we've really seen. But over the next 5 years, we're really expecting that these applications are going to continue to drive bandwidth. Now, the race is on to deliver 400 gig pluggable optics for data center applications to match the 12.8 terabit per second switches. The first generation 400 gig in CFP8s are available now based on 56 gig PAM. But for 400 gig optics to really take off, they need to be in optimized form factors with high faceplate densities like QSFP 56 double density or OSFP. And they also have to be available and priced at the gigabit per second level comparable to 100 gig. And that's a key to, hitting those price points is a key for the transition. And really, the FR, DR, and LR solutions are needed to bring the component count down, decreasing the cost of these to make them competitive with 100 gig solutions. Volume production is also a key in getting to those price points. The path to 400G will not be straightforward, and although the industry would prefer to jump directly to the winning form factors and technologies, it will be a circuitous path, unlike or like what we've seen at 100G and before that at 10G. There's a lot of different options for reach, technology, and form factors: copper, multi-mode fiber, then parallel and duplex single-mode fiber, technology options, NRZ, PAM4, coherent, and then form factor options. We've started here at CFP8, but we expect the likely volume leaders will be QSFP 56 double density and OSFP. There's also options for onboard optics. We'll see where that plays out. And then in the DCI space for embedded optics. Looking at looking at transmission capacity demand, this is really focusing more on the DCI space and transport. But what we're seeing is very strong growth in this market. We're seeing, if you use deployed bandwidth as a proxy for bandwidth growth, or deployed transceiver as a proxy for bandwidth growth, what we're really seeing is the growth rate from 2018 to 2023 of around 30% for bandwidth growth on a compound basis. Our forecast is for 80 petabits per second in 2019, growing to over 200 petabits per second by 2023. We expect that 400 gig will be 50% of the deployed bandwidth by 2022, and well over 60% of the deployed bandwidth by 2023. Now I will turn this over to Mohammed for some enlightening information about a typical 60 seconds on the internet and Fujitsu's view on DCI market trends.
Thanks, Tim, and thank you all for joining the webinar today. I would like to start with DCI market trends we are seeing in the industry. Firstly, yearly growth in DCI traffic continues, evident from various interesting angles. As shown on the chart with some remarkable stats, the amount of data that is being moved around to support services offered online by DCI hyperscalers and others is just mind-boggling. For example, every minute we're watching almost 6 million videos on YouTube and Twitch alone, and are spending $1 million in 60 seconds. Basically, increasing appetite for content and online revenue is keeping the DCI traffic going. Coherent technology's journey towards data center also continues. Developed originally to support long distances and to address multiple use cases and applications, it has really reached a point in its evolution that finally enables IP over WDM application with direct pluggability to layer 2 and layer 3 devices. From line system perspective, open line system concept, though great on paper, where various functions from different vendors can be stitched together for flexibility, lower cost, and avoiding vendor lock-in. But there are only few operators who have the scale, expertise, and resources to support it. Others find it much more efficient, especially operationally, and cost-effective to buy complete DCI solution or line system from one vendor. Next generation of ROADMs supporting CDC architecture and Raman amps are on their way with higher degree counts and port counts. And they're really paving the way for much more agile and flexible optical grid. Zero-touch optical networks are also being worked out with one goal in mind, that is zero human intervention in running a network, including configuration, monitoring, fault isolation, and resolution. Major initiatives from operators and vendors are underway. They're trying to reuse various building blocks that are already available, from zero-touch provisioning, streaming telemetry to adaptive modulation and A to Z service activation. And lastly, on DCI trends, winning formula remains the same based on state-of-the-art technology, an end-to-end solution with best-in-capacity, spectral, and operational efficiency, and optical performance at the lower cost will carry the day. So now I will hand over to Sophie for her view of the DCI market.
Perfect. Thanks, Mohammed. Now, if we look at the traffic that flows through a data center, there's really three major categories. There's the traffic that stays within the data center. There's the traffic that goes between the data centers, and that's really what generates the demand for what's called the data center interconnect links, so the DCI. And then there's the traffic that goes from the data center to all the way to the end user. So the traffic that stays in the data center is set to decline very slightly according to the study, and that's over the forecast period. And by the way, that doesn't include the rack local traffic. So that's really between racks and data that moves within the same data center. If we were to include the rack local traffic, it would really show that 90% of the traffic remains local to the data center. And big data is really the significant driver for traffic within the data center. Now, traffic between the data centers is growing faster than the other categories, and really that high growth of this segment is really due to the increase in content distribution networks, really the proliferation of cloud services, and the need to move data between clouds. And also, there's a growing volume of data that needs to be replicated across different data centers. So this really puts a lot of pressure on the DCI networks and their need to be flexible, their need to adapt quickly to the different bandwidth demands. So I'll pass it over to Tim.
Thank you, Sophie. So in this section, we're going to look at the unique problems and challenges that are facing the DCI optics community. Mohammed will lead us off now and give Fujitsu's perspective on these problems and challenges.
Thanks, Tim. Again. From Fujitsu perspective, we see the major challenge is really that in a race to offer higher data rates and fancier modulation schemes, system vendors are going through an innovation dilemma. Last optical transport reboot started in 2010 with introduction of coherent groom technologies, and both have gone through multiple generations since then. Each time adding more features, becoming more complicated, but also investment heavy. Coherent DSP's summary on this slide shows how quickly technology has evolved since 2010. For example, first generation started with phase modulation, 100 gig per carrier using 65 nanometer process. Coherent DSP is now in its third generation, with speeds up to 600 gig, packing up to 38.4 terabit in C-band, and offering flexible capabilities in same system in order to support short to long haul applications. And then there is really no stopping. Race is on to higher speeds and feeds. ADCs and DACs are reaching physical limits and will need additional, more complicated techniques and components, especially to go beyond 64 gigabaud channels, especially 100 gig and beyond channels. So higher baud rates and data rates are also reaching point of diminishing return from spectral efficiency perspective. On the other hand, prices are being driven down to unsustainable level, and leaving not much of a healthy business opportunity and incentive for innovation. Much obvious from price erosion estimates on this slide. Cost per bit of WDM capacity is down 80% over 2 generations. And that trend will continue. So as a result, vendors who have a better partners ecosystem and can support their own ASIC DSP are better positioned at the cost of narrowing field of players in the market. So the other challenge is that DCI's market is still evolving, and it has a lot of different dimensions to cover for a system integrator. Very broad set of customers with different business models and network requirements. Some customers build their own networks to ensure smooth operation of their core businesses, while others build networks as a service or provide connectivity. Then each of those categories, scale varies drastically from hyperscalers to tier 2 to 3 players. And a set of applications and requirements are pretty large too, from short reach to metro and regional edges and long haul as well. Some need to pair with legacy interfaces and have to consider brownfield applications, while others have more east-west DC traffic to deal with. Some build networks on demand, while others do a one-shot complete build. And their refresh cycle is also driven very differently, either by their customer needs or by technology refresh available in the marketplace to maintain the competitive edge. Some are, like mostly hyperscalers, are early adopters to technology, ready to pay the premium for the latest and the greatest technology, while others wait it out till the technology is more mature, stable, and cheaper. And then there are architectural choices that are made very differently. For example, for network protection, flexibility, future-proofing, and then operational differences in management and control. There are a number of interfaces from NetCom to GNMI to REST need to be supported, automation-related features, management models, network controller positioning, and this really goes on. So a DCI market needs are so broad that it becomes a strategic decision point for system vendors to which part of the market to focus on. Therefore, vendors with broader portfolio and deeper technical roots and really innovative solutions will have edge in the market. I will now hand over to Sophie to discuss DCI challenges Expo is facing.
Thanks, Mohammed. So if we look now, dive a bit deeper into the operational challenges. So as we work with our web scale and data center customers, we've seen that these are some of their most important challenges from an operational side. The first is really the constant pressure on having to increase the capacity of the network. That's the biggest one. In order to achieve this, the data center operators really need to deploy flexible solutions that will allow them to grow and adapt to the bandwidth requirements. The second one, and it's been mentioned a bit in the previous slides, is the constantly evolving technology around pluggable optics. Really to meet specific demands from the data centers, which are typically different from the telecom service operators. The transceiver manufacturers, they are continuously innovating. And this has resulted in a very wide offering in pluggable optics and also an offering that is continuously changing. And that's at a much faster pace than in the past, and Mohammed indicated that a couple of slides ago. So with that comes the challenge of having to support all these different form factors and also managing technology that's not always mature. Pluggable optics are a proven point of failure in the network, and especially when that technology is not mature. And the third challenge really lies in automation of the network operations. Web scales and data center operators have and want an operation model that is hands-off, that require minimum human intervention. Operational tasks like commissioning, troubleshooting need to be very easy, very fast, with minimum touch points, and ideally they have to be done remotely and without having to go on site. Now, if we go specifically into transceivers and pluggable optics, the biggest feedback that we're getting from our customers is really the sheer volume of transceivers that fail. And we've seen very impressive numbers where some technologies, for some technologies, more than 25% of transceivers are found to be defective or not to be up to performance. And that's really received from the manufacturers. So since the evolution of transceiver technology is so fast, many of them are not mature when they go into the network. So when we surveyed our data center customers on the circumstances of the failures, the results really show that most of these failures occur before the actual network is in service. So typically the transceivers fail during the installation or validation phase. And only part of the failures are due to degradation over time or found in the troubleshooting phase. So with the sheer number of transceivers that are being installed in data center, this really poses a significant challenge for the data center operators. The top 3 challenges they've identified are the lack of testing methodologies, trying to understand, what's the root cause of the failures, what's wrong with the transceivers that are failing. And actually the feedback that we got was that many transceivers are returned to the manufacturer with no fault found. And finally, also managing temperature and power consumption is a challenge when dealing with the big number of transceivers. So we'll go to the next section. Tim?
Thank you, Sophie. So in this section, we'll explore new options and solutions, and Sophie and Mohammed will cover some of the emerging interfaces and transceiver types for data centers. We will start with Mohammed, and he'll share his perspective on the transport layer evolution. I'm turning it over to you now, Mohammed.
Thanks, Tim. So as shown on the slide, we clearly see 2 cadence forming up in evolution of transport layer. There is a leapfrog cadence that is taking the approach of making generational shift and breaking new technology barriers in each generation. Not only improving, but leapfrogging the technology to the next set of limits, employing innovative modulation schemes and new constellation shaping techniques. For example, after Gen 2, this cadence delivered 600 gig per carrier, achieving theoretically maximum spectral efficiency of packing 38.4 terabit in C-band. And even 400 gig mode is offered in sort of a done right way, with the right kind of specs and performance. Leapfrog cadence has also reduced the size and the power to under less than 0.3 watts per gigabit. This cadence is built for flexibility, as it offers a number of modes, offer bandwidth variability in true sense. So solution based on this cadence can be used across a wide variety of DCI applications. So basically, while the other cadence is offering limited and incremental improvements, leapfrog cadence is always a step ahead of that with better specs and performance. The next slide, I'll go a little bit deeper into some of the specifics on the DCI application and options. From client optic perspective, we see transition, as discussed earlier, to 400 gig with QSFP-DD in early 2020, with focus on some variants of DD form factor. This will be driven by transition that is happening within the data center to 400 gig packet ports. A quick note on PAM4 technology, it achieves lower cost per bit for 80 kilometer DC application. It is limited, but it's suited for that one application. But coherent technology is also evolving fast to provide comparable price points at higher data rates, while it promises improved optical performance, application flexibility, and it's much easier to design network using coherent technology. Coherent pluggable modules are already commercially offered in some product today, using CFP2 DCR module for 100 and 200 gig. And then 400 gig ZR modules will be a very attractive option for up to 100 kilometer application that will allow transitioning to practical IP over WDM design. There is the ZR minus concept, a dumbed down version of ZR module that is in similar form factor for 100 gig and high rates, will be attractive for shorter distance DC application, for example, data center campus interconnect, DCI. That with further integration can also fit into the SFP formats in future. And then ZR plus technology for longer distances for up to 400 gig rates will cover metro, regional, and long-haul application in some DCO formats. For future transponders, DSP innovation will allow 7-nanometer design with much higher baud rates of beyond 100 gig, possibly, offering 1 terabit plus rates per carrier. And DSP would require new technologies to get there. We had to come up and solve technical challenges to offer 600 gig 64 QAM per carrier offering in the current generation, and the next generation will require to fix much more challenges going forward. But that will continue to fuel integration of packets and optics. We also see that TCI and telco network will start to look alike from architecture and requirements perspective. That will be a huge relief for system vendors as they will be able to build and offer same building blocks to multiple markets as compared to today where they are purpose-built products for DCI market. And now I would like to mention a whole new dimension to pack maximum possible bandwidth on the fiber by introducing a new network function for optical transport wall that is translambda. This is a fiber capacity multiplier function that would transform the way DCI links are architected. I have more detail in next slides. Just like MUX, DMUX, and amplifier and other functions, translambda would become a key building block of future line system architecture. So I will hand over to Sophie to discuss emerging interfaces for data center.
Thanks, Mohammed. So digging into a bit deeper in terms of the data center optics, as I mentioned earlier, the speed at which these transceiver technology is evolving is very hard to keep pace of. The data center operators are asking for solutions that are more compact, more power efficient, that have better cost to reach ratios. So they need this in every segment of the network. So Mohammed covered the optics from a transport perspective, but there's also requirements within the rack, between the racks, and also the DCI link. So it's definitely a challenge for the whole ecosystem to support all of these new technologies and supporting them, developing them, and making these programs commercially viable. In this slide, we show the table from the Ethernet Alliance on the Ethernet interfaces, and the bottom part really shows the emerging interfaces for data centers, and we can see that there's a number of them, number of these items that are in red and green, which are in standardization or in study groups. And so for long-reach DCI, as covered by Mohammed, coherent ZR pluggables that were standardized by the OIF is the latest technology in development, and that web scales are very interested in. They promise to provide very good cost versus reach ratio, and they're probably going to be available in OSFP and QSFP DD formats. For shorter reach, within the data center, there's a lot of effort to make 400 gig cheaper, and not necessarily within the data center, but also a bit shorter reach, allow for high volume 400 gig deployment, new technologies like DR4, 4 times parallel fibers, new proposals like 400 gig FR4 single fiber, 4 times 100 gig CWDM, and even new one not even on the table, 100 gig DR1. So a lot of movement in that area. So if we look at where these data center optics will be deployed, we can see there's quite a range of different technologies that will be deployed between the servers, from within the servers to top of rack, and then between the tier 1 switch, the tier 2 switch, and all the way to DCI. And we can really see the technology that's available today and the roadmap. So there's quite a range. So the flexibility and the breadth of solution that's available is great for data center operators. However, as mentioned before, supporting all these different technologies is a challenge from an operational perspective, and it's also a very big challenge for transceiver manufacturers, for network equipment vendors, and also test equipment vendors to make all these, to be able to support all of these different technology at such a fast pace. Back to you, Tim.
Thanks, Sophie. So we're now moving to the deployment application section, and in this we'll take a look at where and how the approaches can be used and how it impacts the problems and challenges in the previous section. Mohammed will begin this section with Fujitsu's view on evolving use cases for data center interconnects. Turning it over to you, Mohammed.
Thanks, Benga. Sorry. So on this slide, I'll discuss some of the evolving use cases in the DCI space. Some interesting use cases are on the horizon with the impending introduction of pluggable 400 gig and even lower rate 100 and 200 gig ZR modules. One shown on the top is the standard pluggable IP over WDM, where ZR modules are plugged directly to layer 2, layer 3 devices. Another use case shown in the middle is a transitionary application where the ZR is used to transmit 4 by 100 gig mux signal. That is very useful for operators where they would like to take advantage of economics of ZR module while they're still using 100 gig packet ports. And in another ZR-related use case shown in the bottom, it is a 400 gig ZR on one end and a transponder on the other, and does the demux function to connect to existing 100 gig devices. There's also a very interesting use case from brownfield application perspective, where current photonics infrastructure is 50 gigahertz grid spaced. And many operators would like to maximize its use, but are also looking to improve the spectral efficiency. This is where a flexible option of bandwidth variable DSP can really help. For example, a 400 gig based mode that can fit nicely into 50 gigahertz channel can practically double the density on some short distance links. Going to the next slide. This is, again, as I discussed in previous slides, a whole new dimension to maximize fiber capacity is really coming up with the introduction of trans-lambda. Maximizing fiber capacity is always the main goal for any network operator, and as it has direct impact on cost per bit. Industry has been addressing it from a few dimensions. For example, by going to higher order modulation, achieving optimal spectral efficiency, packing 30 plus terabit in C or L band. And then for additional capacity, the next dimension typically is to use L band. However, that requires a new set of transponders and line system that operate in L band. And so that's basically has been the limit, that you can go to higher modulation, higher data rates, you can go to additional band, but that has been the limit. but I think that glass ceiling has been broken with translambda. Fujitsu has created a whole new dimension called that is basically a new function in the architecture of optical transport network. What it does is it optically converts wavelength of input optical signal from one band to another, or within the same band in a controlled manner. So translambda packs multiple transmission bands into single fiber by converting WDM signal from existing C-band equipment to L and S-band for transmission, achieving extremely high capacity WDM, like 3 times or higher. And the beauty of that is that it requires no additional type of equipment. So it doesn't require L or S type of equipment. A capacity example is like 76.8 terabit on the fiber using 192 channels of 400 gig, transmitting over C, L, and S band without having L and S band equipment. So basically, translambda is the latest innovation and cost-effective solution to multiply fiber capacity. And if you had not heard of this before, this webinar is where you first heard about translambda. I will now hand over to Sophie for discussing commissioning of DCI links.
Thanks, Mohammed. So here I take more a view from an operational perspective in the context of installing, turning up, and troubleshooting data center interconnect links, as well as installations inside the data center. So the speed at which data center operators and web scale companies are evolving their network and their size really requires an absolute minimum touch point during installation. So automation is really critical. However, there's some best practices that are required to make sure that the network will run smoothly. This starts from the basics, like fiber characterization and connector inspection. It sounds basic, but as basic as it is, dirty connectors still account for the large majority of fiber network failures. Inspecting and cleaning is the most basic and most essential step. And now once the physical layer is validated, the typical next step is really to qualify the transport layer. And the first step there is to make sure that the transceiver itself is fully functional. As mentioned earlier, we've had large web scale companies tell us that they got over 25% failure in transceiver, which is an astounding number, but they receive these directly from manufacturers. So typically, the typical transceiver testing really validates a number of different critical parameters of the transceiver itself. So being able to validate pin validation, optical power, power consumption, temperature, crosstalk. So really, in terms of before putting any transceiver in the network, it needs to be validated. Obviously, because there are so many transceivers, that needs to be done very quickly. It cannot be a long test. It needs to be done easily and quickly. And finally, for the DCI links themselves, they need to be qualified for quality of service, and this is typically done with standardized tests like Y1564 or RFC 6349, and the SLA of the link is fully validated, measuring key parameters like throughput, latency, packet loss, packet delay variation, and typically they will save a report and will be saved as a reference. Either it's done directly by the data center operator or even a third-party telecom provider that provides that link. Inside the data center, as links are shorter, typically the data center operators will only test the transceiver. They won't do a performance of the links. All the transceivers, as well as the DAC cables and the AOC cables, need to be qualified to make sure they work properly. So that's really from an operational view. Now we'll move to sponsor approaches. Tim?
Thank you, Sophie. So in this next section is the sponsor's approach, and we'll take a closer look at each of the sponsor's approaches to solving the problems and challenges facing the DC optics community. Mohammed will start with Fujitsu's DCI solutions, followed by Sophie outlining EXFO's flexible test systems. Turning it over to you, Mohammed.
Thanks, Tim. Fujitsu offers a complete DCI end-to-end solution to address end-to-end DCI needs. It's a complete multi-hall solution that has a comprehensive suite of products and services specifically designed for data center operators for both ROADM and FORDM-based applications. Various Onefinity platforms can serve as individualized functions or as complete integrated solution in a DCI application. The T600 and T100 transponders provide line-side transmission from 100 gig to 600 gig per wavelength, while Onefinity L1 series platforms perform flexible spectrum multiplexing and DWDM ROADM functions as well as inline amplification. The Onefinity platform's fully disaggregated architecture also means that each network element can work with non-Onefinity systems. And lastly, the Virtura network control solution provides SDN-based network management and service delivery. On this side, I would like to bring out the main driving factors which we build our Onefinity platform on, especially for T600. The T600 blade is a 2.4 terabit bandwidth variable muxponder that provides hyperscale optical transport with full flexibility, highest capacity, hooks for operational readiness, and total security, both from management as well as data plane perspective, supporting greenfield and brownfield data DCI applications in short reach, metro, long haul, and ultra long haul configurations. So I will hand it over to Sophie for her view.
Thank you. So the approach from EXFO is really to help our customers, which are the network equipment manufacturers as well as the data center operators and web scales. It's really to help them with their operational challenges. So first, it's to help with the challenge of supporting the constant evolution of the different pluggable optics. So as mentioned throughout the webinar, from a test equipment perspective, our customers need to be able to test all of these existing transceivers and also the ones that will come out in the future. As we saw earlier, there are new MSAs coming out regularly, and the way that we've addressed this is that we've developed flexible test solutions that can actually adapt to the different transceivers. It's a system that we call the open transceiver system, and when a new pluggable optics becomes available, our customers don't have to change their entire test equipment, and they can simply change the transceiver system, and this really provides a lot of flexibility. And the second way we're helping our customers is in automating the different testing steps that are required for turn-up, troubleshooting, and commissioning. For transceiver for testing the transceivers, for example, we have a single one-button test that can validate any type of optics and check all the key parameters, as mentioned before, like temperature, power, register, alignment. That's a test that we call iOptics. Really, the goal is to have one simple push button that tests and gives a clear pass-fail indication. So just pass-fail and make sure the transceiver is good or bad. Also, from an automated testing approach, our solutions allow minimum touch point. So as data center operators, they typically have very little staff on site. at the data center. Most of the testing, validation, and troubleshooting has to happen in a remote fashion. So Expo, we provide solutions for validating the different links and done all remotely with a centralized remote control. So this is really performed with automated test routines and that measure all the key SLA parameters, but done remotely without the need for personnel on site. So that's our overall approach to the main challenges. So back to Tim for the conclusion.
Thank you, Sophie. Okay, to conclude, the fundamental drivers are in place requiring bandwidth expansion and setting up for continued growth and evolution of optical networks, including test and measurement equipment to support them. Hyperscale operators and data center operators need faster innovation to meet the approximately 40 or 60% growth rate inside of data centers, and for data center interconnects, 30 to 40% compound annual growth rates. Flexible test systems are an important piece to keep up with the new transceivers coming to market, as we've heard from Sophie. And flexible rate transceivers enable a single product to service multiple network implementations, which helps cover the overall development costs and supporting these faster innovation cycles. At IHS Market, we're expecting 400 gig plus, so 400 gig, 600 gig starting deployment here in 2019. We're going to see 400 gig datacom starting in earnest in the second half of 2019. We expect that 400 gig ZR we'll start seeing some prototypes potentially at the end of 2019, but expect to see that market to begin deployment in the second half of 2020. And then we'll maybe see ZR plus and ZR minus for ZR plus for amplified applications, ZR minus for lower level applications like 40-kilometer links, unamplified links. In general, IHS Market forecasts that the deployed bandwidth for coherent interfaces servicing DCI will grow at over 30% compound annual growth rate between 2018 and 2023. And the client-side market, including service providers, but mainly driven by data center operators, will grow at over 40%. I hope everyone found this webinar useful and got some good information out of this. That concludes the webinar. We will now transition here into questions and answers. So I think with the first question that I'm seeing is that's interesting. Mohammed brought up a very interesting new subject around optimizing fiber infrastructure. So the question, Mohammed, is how does Translambda change the dynamics and economics of DCI networks?
A great question, Tim. I think Translambda will basically change the way DCI networks are designed and operated today. I think it will benefit operator in multiple ways. For example, savings on sparing, because they just have to use one type of equipment. Onboarding cost, integrating into their OSSs. There is a lot of savings there because, again, we're talking about reducing the number of type of system that has to be designed into the network. Also taking advantage of optical spectrum for which systems are not even available. For example, there are no systems available for S-band today. So it's very unique. And again, this is just first application of Translambda we're talking about today, which is maximizing the capacity, multiply the capacity on the fiber. But there are a number of additional very interesting use cases which will be enabled by Translambda going forward.
Thank you, Mohammed. Thanks for enlightening us on that. The next question that I have concerns test and measurement equipment. Sophie, how are there specific differences for 400 gig in testing relative to what's been done for 100 gig or other line rates?
Definitely validating the transceiver is critical. So most of the current, if you look at CFP8 is pretty stable, but if you look at the current QSFP-DDs and OSFPs, most of them are very early versions. And we've seen that many of them are not completely stable, and testing the transceiver is from a 400 gig perspective, and especially with the price where they are right now is critical. So we've seen, in terms of the key issues we've seen there are overheating issues, bit errors over time. So testing the transceiver itself is critical. From a QoS or performance testing perspective, we're not seeing much. There's not much difference from what was done on the 100 gig as before. So it's typically bit error rate testing and performance testing, like RT2544 for the key parameters. That's pretty much it.
Thank you, Sophie. Okay, the next question from Mohammed. Can you outline some specific use cases for flexible rate transceivers in DCI networks?
So in case of flexible rate, I guess we're talking about multi-rate, or we're talking about the same form factor addressing 100, 200, and 400 gig.
I believe it's that form factor addressing 100, 200, 400, 600 gig type of thing.
I see. So I think those, again, as I mentioned, some of the use cases in the slide, there is a transitionary period where some of these rates will be very helpful. And also, as the transition to 400 gig is happening over a period of time, there will still be some packet ports which will be available and need to be used, and that needs to take advantage of the ZR coherent optics. So in that case, those flexible rate can help move from 100 to 400 gig in a transition manner.
Okay, thank you. One more question. I think we have time for at least one more question here. And this one also for you, Mohammed. The question is how to get a cost-effective transition from OTN switch topology to future DCI topologies.
Oh wow, that's a very broad question. I think I have to answer that. I will need to understand the network it is today, and what are some of the requirements that is driving it to go to DCI. So I'm not sure it will be fair for me to answer that without the specifications.
Okay, and we will follow up with the questions.
Sure. Yeah.
Offline, so we can certainly do that offline. Let's see. Another question I think was covered, but I'll go through this again. What is the timing for 400 gig ZR? So we're expecting that vendors will start having hardware available for prototypes in the second half, probably fourth quarter of 2019, and expecting initial deployments of 400 gig ZR starting the second half of 2020. Alan, do we have time for any more questions, or?
No, we are at the top of the hour, Tim. We're going to have to wrap it up here. So I will,
Okay.
I'll take it from here. So thank you, everyone, for participating on our webinar. Thank you for submitting all your questions and comments. We did get quite a few, and we kind of ran out of time, so our panel will be following up with you via email. I want to thank Sophie and Mohammed for sharing your expertise with us, and of course, Tim for leading our discussion as well. An archived version of this webinar will be made available shortly, so feel free to come back, view this session again, or even pass it along to your colleagues. Now you will see a short survey pop up at the conclusion of our webinar, so please take a few moments to fill that out. And lastly, make sure you continue to follow us on Twitter and LinkedIn for future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.